Welcome to this explainer. Today, we're going on a bit of a wild journey through the very fabric of reality itself. We're diving deep into Dr. Ahmad Rayhan's research, which, and this is super cool, connects the universe's vastly different scales through one single mathematical thread. I mean, from the geometry of quantum particles all the way to the electrical grid powering the device you're using right now, let's explore how it's all intricately linked. Now you might be wondering, what could possibly connect the simple, everyday geometry of a circle to the mind-bending 11-dimensional physics of string theory? It sounds completely like sci-fi, doesn't it? But as we trace a seemingly abstract mathematical concept through the physical world today, you're going to see that it all hinges on one very specific kind of rotation. So let's jump straight into part 1, math's most elegant rotation. Okay, take a look at Euler's identity. The standard view usually treats the imaginary unit I as just, well, the square root of -1. But Dr. Rayhan's analysis urges us to look at it differently, to view I as an actual physical action. You see, multiplying by I on a complex plane isn't just some abstract calculation. It's a perfect, counterclockwise 90-degree rotation. It's a literal quarter turn. Watch how this builds. It's actually really beautiful, creating this perfect cyclical clock face of physical quarter turns out of pure math. So I to the power of 1 is a 90-degree turn. Multiply by I again, and you get -1, hitting the 180-degree mark. Do it a third time, that brings you to 270 degrees. And a fourth time, well, you're right back at +1, completing the entire circle. This simple geometric engine actually drives some incredibly profound physical phenomena. Which brings us naturally to part 2, electromagnetism and phase shifts. Here's where the pure math actually gets physical. You know, Michael Faraday observed that changing magnetic fields induce electric currents, but the math governing these waves shows the exact same 90-degree geometric shift we just talked about. The electrical response actually deviates from the magnetic push by a quarter of a wave, so literally a quarter turn in time and space. And this brilliantly illustrates the duality in our own electrical grid. Just think about the components powering your electronics. Inductors introduce a positive 90-degree lead. Essentially, they take a quarter turn forward, which mathematically is just represented by multiplying by our old friend I. Capacitors, on the flip side, feature a negative 90-degree lag. They take a quarter turn back, represented by negative I. So it's Euler's imaginary rotation mapped directly onto our alternating currents. Looking at this breakdown, you can see how electrical and magnetic fields interlock. It's like a perfectly timed dance, and it's governed entirely by these I rotations. An inductor pulls the phase forward by 90 degrees, while a capacitor pushes it back by 90 degrees. This precise geometric balance is actually the entire foundation of complex electrical engineering. And this rotational logic even scales way up. Our huge three-phase power grids naturally incorporate 120-degree phase shifts, which Dr. Rayhan generalizes as multi-limb symmetries, basically cutting the circle into balanced rotations. But here is the ultimate question. If this logic governs massive macro-level power grids, does it also apply to the microscopic quantum world? Let's find out in part 3, reimagining the quantum atom. So at the quantum level, things usually seem chaotic and totally different from classical physics. But if you really look at the equations, a different story emerges. Bohr's quantized angular momentum dictates that electrons orbit in fixed circles. Plus, the Schrödinger equation, literally the bedrock of quantum mechanics, incorporates complex time evolution. It has an I built right into it. And the azimuthal wave function embeds complex phases using Euler's formula. It turns out the quantum world is functioning remarkably similarly to the geometric rotations of our everyday electrical components. Dr. Rayhan offers a real game-changing thought here. He suggests, what if we reimagine quantum rules simply as microscopic electrical circuits guided by these exact same geometric quarter turns? So instead of some chaotic quantum haze, an electron's orbit acts like a microscopic multi-limb circuit experiencing Faraday-like inductions. It gives us a tangible, geometric reason for why quantization rules even exist in the first place. Now let's take this even further. Part 4, String Theory's Cosmic Dance. In string theory, the universe's fundamental building blocks aren't tiny dots, but one-dimensional vibrating strings operating in higher dimensions. And guess what kind of math this world heavily relies on? Complex coordinates. The world sheet theory mapping how these strings move, and the complex Calabi-Yau manifolds they vibrate inside of, they all mirror our mathematical circles.
Even more incredibly, string theory features a concept called T-duality, which literally swaps a string's momentum with its winding mode, exchanging how it moves with how many times it wraps around a dimension. The parallel here is absolutely stunning when you step back and look at it. On one side, you have everyday electromagnetic phase shifts, inductors and capacitors taking 90-degree turns to balance an AC circuit. And on the other, you have string theory's T-duality doing this complex exchange in higher dimensions. The intricate cosmic dance of string theory perfectly echoes the circuitry inside the screen you're looking at right now. Bringing this all together leads us to Part 5, a unified physics future. Ultimately, Dr. Rehan's research suggests that a unified rotational complex lens could actually bridge the gap between classical and modern physics. By just tracking this simple quarter-turn rotation of the imaginary unit I, starting from pure math, to Faraday's law, to Bohr's atom, and all the way to speculative string models, we find a common geometric language. This isn't just about drawing fun parallels, it prompts some seriously exciting new avenues for unification research. It really suggests the universe, at literally every scale, just loves the symmetry of the circle.
Which leaves us with a profound mystery to ponder as we wrap up this explainer. If this simple geometry, a basic mathematical 90-degree turn, dictates reality across such immense, seemingly unrelated scales, what else are we missing? What other beautiful symmetries are just hiding in plain sight, waiting for us to look at them from the exact right angle? Definitely something to think about the next time you plug a charger into the wall. Thanks for joining me today, and I really hope this sparked some new curiosity about the absolutely elegant design of our universe.